topic of my study is modeling and performance evaluation of an additive manufacturing process designed for aerospace application, and also in consideration for perspective for rail manufacturing. A lot of discussion has been around Industry 4.0, and it's interesting to know that no one has actually mentioned additive manufacturing. What is additive manufacturing? It is an upcoming manufacturing process that people are really studying about. So according to American Society of Testing and Material, they define additive manufacturing as a process of joining materials to make objects from CAD model, and it's usually done in form of layer upon layer as against conventional way of manufacturing. There are basically about 7 techniques when it comes to additive manufacturing, transforming a model to a real object. Firstly, you have the CAD model. There is a file called STL file that is used to transfer the CAD model to the main machine, which is, we have the third one is file transfer, the machine setup. Afterwards, there is what is called part removal. Then what is produced. Then after the whole production, what is called post-processing activity. So most industries, service industry, most manufacturing industry are actually looking into how they can take advantage of additive manufacturing, this upcoming process. But as sweet as it is to discuss about additive manufacturing, there are limitations around this additive manufacturing technique. So from my study, I use what is called SWOT analysis for evaluation of what is around additive manufacturing. Look at the strengths, the opportunities, the weaknesses, and the threats. That led to the problem statement. From the strengths angle, it's a way for sustainability via limiting and improving supply chain. We have complex shapes that are difficult to manufacture through conventional way. It can be easily manufactured because there's no need for welding and clamping. It is limited. The high strength to weight ratio, because of the materials in use when it comes to the process of additive manufacturing. Mostly for aerospace in particular, there's what is called titanium alloys. So those are the materials in consideration for aerospace. It reduces material wastage compared to conventional way of manufacturing. Those are the strengths and the cost and time savings. And the opportunities, it's from projection, it's going to lead to intelligent way of manufacturing. New researches are evolving, like what I looked into. There's what calls hybrid system. Both the conventional way of manufacturing and the additive way, combining it to form hybrid manufacturing system, making design more flexible. Those are the strengths and the opportunities. Now, regarding the weakness that led to the problem statement, according to for this additive manufacturing, there is usually what's called staircase error. As this thing is producing, it generates irregular production. So that is one of the limitations. Error resulting from rough surface finishing. Compared to conventional way of manufacturing, you cannot get exactly like what the production you can get is what is called near net based shape of production. So also as it is now, limited education is around additive for people that understand what this project is all about. Material limitation, it's limited to some certain materials. The threat, it can lead to what's called defect. When there is a production, there's usually what is called porosity. The cracks, it can generate a crack compared to conventional. So that is the reason why I looked into this study to attend to one of the weaknesses. So going forward, the objective and the aim of studying this project is to model and evaluate the production process of an additive manufacturing, basically for aerospace parts fabrication, and in order to check for quality. And the objectives are as analyzed to carry out a technical analysis of process with regards to aerospace, to develop an integrated design model that can ensure quality production. Thirdly, to conduct a mathematical model and dynamic simulation for the product of additive manufacturing. Then it led to this research question of what determines what's called near net shape for aerospace components. What are the key factors to investigate when it comes to additive manufacturing? And what are the things that determine quality production? And how can the results model can also be optimized to meet other production systems? Firstly, for the first objective, I look into carrying out what's called a technical analysis of all. There are about 7 production system techniques under additive manufacturing itself, but the one relevant to aerospace application. So I discover what is called power bed fusion and what's called material extrusion. There are 2 techniques for. There's what is called polymer and for metallic. The consideration here is for metallic, which led to the discovery of power bed fusion. So from the literature, that's a method from the literature, what's called morphological box, that determines which the techniques of determining which production techniques is more benefit to the thing we want to determine, whether for rail manufacturing, for aerospace. So this was used to carry out the exact production technique for aerospace using another framework discovered from the literature for the first objective. Then objective number 2, I look at into the whole value chain of what can lead to quality production. So the focus is on the build, the aspect of the build lot and manufacturing lot. So from there, I look into another literature to understand what is called guide to principle and guide to rule. So this was used that led to my own formulation, that led to this framework I use for objective number 2, that ensures quality production of additive manufacturing, including what is called these other decision factors that can ensure quality production. The conclusion for objective number 2, the goal is to look into determining what is called design for additive manufacturing. When it comes to conventional manufacturing, there's what we call designing for conventional manufacturing. This one I look into what's called design for additive manufacturing in order to extract the principle guiding and the rules that can ensure quality production. Going further, empirical evidence can inform whether this was actually it can be useful. Objective number 3 led to empirical performance because the topic has to do with performance evaluation. So this method was used as a guide for the experimental aspect. I look into the terminology, the process itself, the test method, and the design that led into the whole study of this method. The terminology, quality as it is actually ambiguous in nature. So, but what this study has to do with is studying the surface quality of the product you have. So, and quality is mostly measurable regarding to property and roughness parameter. So, roughness parameter is determined with what is called ROUGHNESS. But in most cases, the other methods that can be used to determine quality are listed. There's what called visual inspection, and there's what they call measurement in order to determine whether it's conform with the design. The third one is functional testing to assess mechanical characteristics. So this study is carried out in collaboration with Council of Scientific of Industrial Research, which is called CSR. So I use their production system using this parameter. This parameter was deduced from literature review to carry out the production of the component. This is the schematic of the production itself, which is called selective laser manufacturing for mechanic production with respect to aerospace production. This is used to know whether it can be used for rail car manufacturing too. So these are the techniques that I used to determine what I'm going to carry out for the products I produce. from this production system. So these specimens were produced, and this idea was used to determine the surface area using what is called surface measuring equipment. What was carried out was manufacturing and testing for the performance and also the measurement. So roughness itself is a geometric deviation from a reference. There is a point of determination. Then if what you produce is in reference with your input, that determines the quality production. Then this data was gotten from the production. Then going further, I look into all the optimization methods that can be used to carry out, to check for the optimal production. The mathematical model used to guide this project to determine quality production. There's what we use control of surface roughness. This mathematical model was used to predict the quality of what you can get from the production. And I don't want to use that to take our time. This is just a depiction of the results gotten. There are a lot of results in the actual sense regarding this, but this is just a depiction from the result obtained when we compare what was manufactured with what was optimized. What was gotten says normal probability plot. The software used for this technique is what's called Design Expert of version 10. So the techniques, the results got in the normal from the determination. It says normal probability plot of the this residual check. Okay. So there are a lot of parameters used to detect the roughness, the values gotten, and they were compared with from the. So yes, the benefits of this study, there are a lot of demand for efficient manufacturing compared to manufacturing actually generates what's called revenue. It generates to any nation. So manufacturers are ever looking for an efficient way of production, which is under the revolution of Industry 4.0. So this evaluation is in essence to carry out in order to understand the product, the process, and the application. And when I analyze a process, experiments are often used to evaluate which process input have a significant impact on the process output and what the target level of the input should be to achieve a desired result. The study is to lay a foundation whether additive manufacturing can be used for other processing. And going by this study, our results shows that it's the optimal from the optimization technique, it can be used compared to conventional way because it's more efficient than the conventional way of manufacturing. So, future work, rail industry also can be looked into for what is needed for their products when it comes to product life cycle. So, more study will be carried out, especially when it comes to rail industry. Laser welding is mostly used. So all those things have to be checked whether additive manufacturing process can be used for it. The achievement so far, there are 2 journal articles about to be submitted. 2 book chapters out of this study came out. 3 conferences, both international and local, came out of this study. And the study at the moment is discussing about chapter 3 before a thorough discussion of the results. Then the collaboration is with Council of Scientific and Industrial Research, which is called CSIR, specifically National Research Center, and the aviation industry, which is called AEROSPACE Aviation Industry. Out of the conferences, I carried out an evaluation within AEROSPACE aviation industry. So these are the list of the articles. I want to appreciate the Bella Chair, the university, and the NRF, and especially and also the Council for Scientific and Industrial Research. Thank you.
documenting your work and the extent to which you have gone in achieving your objective stated for your Doctor of Engineering Studies. And we need to take some difference in this section. I need criticism. I need questions that will make this work be ready for submission. Because as he said it's at chapter 3, and he has turned out some outputs. So I think after this, he should be ready to be submitting his work for assessment.
This study, if you have a production, it will be different to the other production. Those are the things we are trying to, the qualities, the mechanical things we are trying to check. What is leading to, if you can have a smooth production, then the next one it can be rough. Those are the things we are trying to analyze whether additive manufacturing can be actually used for general production. Or so that's the essence of converting different specimens and the data gotten from both all the per specimen. This my measuring equipment was used to carry out the data for gotten for one for the other. So all those things were analyzed in the table. There are a lot of data. This one is just a representation. Yes, the emphasis here is on surface roughness. I mentioned it has to do with the quality of the obtainable products gotten from additive manufacturing process, then with conventional manufacturing process. This, like I did mention, both will be documented to see whether that is actually being said. The conventional way is still it has the smooth, mostly smooth surface. But additive manufacturing process, how we can mitigate and limit roughness is part of this performance evaluation this study carried out. So the focus is on the surface roughness. Mostly, the third objective is on the surface roughness. After determining the techniques used, then the focus is on the quality of the surface roughness.
Well, my question though is, as we know, there are many other characteristics of materials than roughness, the surface roughness. Why select surface roughness, particularly given, as it's been pointed out, that the whole point of additive manufacturing is you can manufacture very complex kind of structures. Why surface roughness instead of textile strength or some other characteristic? Is there some study that said that roughness was a major concern in the airline industries because you're using additive manufacturing for airplane wings or something? I mean, you have to have some rationale for using that as your one measure.
Okay.
That's not coming out.
Okay. I got your message. I will take notes. The cost benefit has been looked into by from the other literature that additive manufacturing process is more beneficial compared to from the cost benefit for other analysis. So that's why I'm not really looking into that. Then I focus on the quality of surface roughness, which is part of my aim and objectives. So the cost benefit has been mostly trashed by other researchers.